about the intersection. Do you remember what intersection means?
Where they meet.
Where they meet. So intersection, what's the symbol for intersection?
The bracket.
Upside down U. So if I ask for the intersection, you're asking for 3, 4, 5, 6, 7. Intersection, right? This is not the answer. 3, 7, 8, and 9. Okay. What do they have in common?
3 and 7.
3 and 7. How do we write that? Yep.
Bracket.
Not bracket. What's it called? Brace.
Brace.
3 and 7. Okay, roster just means you list them out. Okay?
Wait, so is the second one an intersection? That's the intersection? The 3 and the 7, is that the intersection?
That's the answer, yes.
You just haven't put, so that's the...
She's replaced the and with the intersection.
Yes. So the next one, we're going to replace the and with a union sign, which is a U. So now we're going to do 3, 4, 5, 6, 7. Union 3, 7, 8, and 9. Yes.
Okay, so that's the answer for the top one? That's it? 3 and 7?
Yep, this one's done.
So the same one?
This is finished. Same sets, different questions. So now they ask for the union, and the union means everybody. Now, I asked for set builder notation. We're going to write it in roster first, because that's what I think will help you understand. Okay, then we'll do set builder. So roster, who would you list if we were going to do roster?
3, 4, 5, 6, 7, 8, 9.
7, 8, 9.
Also,
They just put them together, buddy.
You just put in what they have, what's the say?
roster.
So, union means everybody, every element has to be there. So you go through. We have 3, I wrote it down. 4 is written down. 5 is written down. 6 is written down. 7 is written down. Okay, 3, I already have. So do I need to write it again? No. 7, already have. Don't need to write again. 8, got it. Don't need to write again. 9, need, right?
Yeah.
So we got to write again. Union just means you have to list everyone that's in both of them. Okay, now we've got union, but now I said set builder. What's that?
You gotta word it out.
Yeah.
That's not the answer?
This is roster. Nope. I asked for set builder notation. You remember that looks really weird.
X is a natural number less than 6.
How did you get less than
described
6?
but not listed.
Correct.
Okay, so
So how do we start? What's symbol? Oh, what symbol do I need?
X is
The set. Now what?
X.
Containing X
Dash,
such that.
such that.
Now, there could be lots of things.
We gotta have a dot, dot, dot.
No, you got
A 3 dot 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 7.
put 9.
No, what?
But a 9?
Yeah, it's
107 X.
Just 9?
3 dot, 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 9.
3 dot dot dot. There you go. That one.
Okay, we can't do that because that's not how it works. But we could
Put
put like
a
this.
comma
So you want the 3 here and the 9 here.
Yeah.
Okay, where's X at in between all this?
Between the 3 and the 9.
So what is X compared to 3?
Greater than.
Greater
So
than 3.
X, I'm going this way, right? So if I put a greater than or equal to, it looks like that.
Yeah.
Because 3 is less than or equal to X. And what's X?
Less than or equal to.
I would take that.
Oh my god.
The heck?
That could be
is
1.
this?
What I normally see is something like this. We would start to set X such that, let's say X is greater than what?
3.
Nope,
9.
2.
2.
Oh, yeah.
Oh.
Because it's not.
It's not equal to, so what's greater than 2 and
Less than 10.
less than 10. Okay, I should have put X's and integer. Greater than 2 and less
Then 10.
than 10. There's another way to do it.
Why is that one equal to the?
Because it's equal.
We put an equal sign here. Because it can be less than or equal to. If I just use less than here, I'd have to put a 2 there.
Can you put?
So I could have written this like this. Hang on. X is, or 2 is less than X, which is less than 10. That would be the exact same thing as this. All right, good. Anything else? How about X is an integer between 2 and 10?
Sure, totally.
Totally works. Lots of ways to write this. You could all write it different, but as long as it describes that set of numbers different. Set builder.
Okay.
Are we there?
Got it.
Okay.
Step 3.
Ready?
What?
You keep going.
For the catch.
Okay, we've already talked about these. Remember we went through our little thing? Like when you were little, how did your mom teach you to count?
Yeah, we don't need to do that.
Okay, so I should not have to go through this again.
Nope.
But you need to know this. All right, we're going to start here. I'm going to start with one of them, and then you're going to do the rest of them by yourself. You with me? So we're going to do the first one together. We're going to do -9. Right. Is -9 a natural number?
No.
No. Is it a whole number?
No.
No. Is it an integer?
Maybe. I'm not
Yes,
sure.
because negative is the, yes, because that's when you learn to borrow money from your mom.
Yeah.
Okay, so if it's an integer, is it irrational? Yes.
So if it's one thing and then it's the rest of the thing.
Because look here, see how the integers are inside the rationals? So all of these are rational numbers. The naturals are rational, the whole numbers are rational, integers are rational.
So rationals are everything but irrational.
Yes, rationals are everything but irrational
Okay.
and imaginary. Okay, try -1.3.
That's only irrational.
What's irrational mean, Christian?
I don't
Give me an example of an irrational number.
know. Is that the thing that repeats? But it keeps on going, or does it stop?
Okay,
Hi, so it keeps on going but doesn't repeat.
there you go, that's irrational.
Okay.
So what's rational?
Goes forever.
It can go forever in a pattern, or it stops. So, what's -1.3? Goes forever,
Yeah.
or stops, or has no pattern? Which one? So, is it rational or irrational?
Rational.
Rational. So -1.3 goes here. Okay, do the rest with your group. Remember. I know. Okay, 0. Is it an
Whole.
integer or natural?
No.
Whole.
Yes.
Yes. So then it is also
Rational.
an integer and a rational. Is it irrational? No.
Because it's not a 1, 2, 3.
Natural. How'd mom teach you to count? 1, 2, 3. Then the little brother was born. Took away everything.
9, 0.
And then you have 0. Whole numbers. Okay. 0.3 repeating.
No,
Rational.
Rational. What is 0.3 repeating?
0.3.
As a fraction.
1/3.
1/3.
Oh, okay.
Got it? So is it a natural? Whole. Integer. Rational.
Yes.
It repeats. It has a pattern.
So rational has pattern.
That's my own house.
Irrational does not have a pattern. So pi over 2.
Irrational.
Irrational. It's got pi in it.
And that's the only one it can
And that's the only thing it can be. Square root of 9. Natural?
Natural. Yes.
Natural. So what is the square root of 9?
3.
3. So since it's 3, it goes here. So now is it a whole number?
Yes.
Yes. Is it an integer?
Yes.
Yes. Is it irrational?
Yes.
Yes. Is it irrational?
No.
No. Square root of 10. Irrational. If you type it in your calculator, it goes on forever with no pattern. No pattern means we don't like him. Okay, getting better?
Yeah.
All right.
I think I did wrong.
Fair enough. Okay, these, just a reminder. A is less than B means what? Who's smaller? B is bigger than A, right?
Yeah.
A is less than or equal to, what's the difference?
Because it could be the same.
Could be the same thing. This one? Greater than, now who's bigger? A, here? A is greater than or equal to. Okay, absolute value. Okay,
Everything.
distance from zero? Yes, it's always positive.
Something else.
Thank you. Okay, always positive. A is greater than zero. What kind of a number do I have? A positive number. So if I'm taking, so this means positive. If I'm taking the absolute value of a positive number, who do I get back?
141.
The
The number itself, right? So A. So an example would be the absolute value of
4.
4 is a positive number, and that's going to equal 4. Good? Okay, now let's go. A is less than 0. What kind of number? Negative. So this is a negative number. So now, when I take the absolute value, now A is negative, of a negative number, what do I get?
The positive number.
Yeah, I get the opposite of A. This means opposite, not negative.
Yeah.
Okay, so give me an example. Absolute value of?
Negative 4.
Okay, fine. Negative 4 equals
4.
4. Because I'm getting the opposite of negative 4.
Yeah.
Good?
Yeah.
All right, here. Absolute value of 3? Negative 4?
4.
Awesome. Why do you think I put this
7.
one up here?
Because
Because that's going to be 3 no matter what. It's going to be negative 3, and then it's just 3.
Okay, absolute value symbols are grouping symbols, right?
Yes.
They have to be done first. A lot of times kids say, I take the absolute value of 7, which is,
that's 7.
and then they take the absolute value of negative 10, which is 10, and then they get what for it? 17. That's wrong, right?
Yes.
So the first thing you have to do is inside, you must do this. Like parentheses, exactly. What's that? Bob? 0.
Why is there another equal?
Because if it's a negative, it's
Over
going
here?
to be the
Yeah.
opposite.
Okay, up here, if you did this technically, the absolute value of negative 4 is equal to the opposite of negative 4. Well, what's the opposite of negative 4?
4. I got it.
Oh, so you just, so you skipped it up.
I skipped it because you guys skipped it. Okay. I was fine with that. Okay, fine with that. Are you fine with it?
I am now.
Okay.
I was just like, wait,
Are we better now?
so 2 plus 2 does not equal 4, is what I was saying.
All right. So 7 minus 10 is,
So negative 3.
and now we take
The
the absolute
opposite.
value, which is 3. So absolute value symbols work like parentheses. Your turn. Go. You have 2 of them. Already did them?
You and
Okay. What did you get for this one, Matt?
3.
This one, Rachel.
5.
Awesome. Because you had the absolute value of what in here?
Negative 5.
Negative 5, and the absolute value of negative 5 is 5.
5.
I would really like to see that step. If possible, that would make me happy. Okay. Okay, when we find the distance between 2 numbers, you just subtract them. So what's the distance between 10 and 3?
7.
Okay, why didn't you tell me negative?
Because you
Because
started.
it doesn't matter. It's still, it's just.
Actually, it is negative.
The distance, so it's just 10 and 3.
Absolute
It's
value.
What did I tell you the distance always is?
Positive.
Positive.
It's always positive.
So can you subtract them, you would actually still take the absolute value of the answer.
Yeah.
So if you're on the line of scrimmage, if you move backwards 7 yards, which I heard happened a lot,
Yes.
That's not gonna happen no more.
all right. Anyway, so if you move backwards 7 yards, how far did you move?
7 yards.
7.
It doesn't matter.
If you move forward 7 yards, you still move 7. All right? So you still move 7. Doesn't matter which direction. It was still 7 yards. One was bad and one was good. Okay, the distance between negative 3 and 14. How would you do that?
It's 17. We subtract the negatives, so negative minus negative is 17.
Okay, so when you're saying that, you're taking 14,
Negative 14.
no, minus a negative 3 is what you just said.
Okay, so it's plus.
So this becomes a plus, which is
You change
17. The absolute value of 17 is
17.
17. That's totally fine.
Yes, ma'am.
Now over here, I did negative 3 minus 14, which is negative 17, which is still 17. Doesn't matter which direction you subtract them. No, because you're going to take what as the answer.
Absolute value.
Very good. Your turn. Go. You got 3 of them.
Do I get these right?
You did them already?
Why not?
So somebody explain to me how you did this
Negative
one.
4 minus.
Draw a line. I put it on a number line.
Oh, well, I'm not going that far, Christian.
Oh,
All right, so absolute value of what?
Negative 4 minus.
Like this?
Yes. Negative 17. Keep changing.
Tell him how to do it.
It's gonna be negative.
It's negative 4 minus negative 13.
We have to write that stuff out. Do you want to see that?
Well, what did you get? You got 17 for your answer, yes, but that's wrong.
Wait, what? Write it out.
Why? What's negative 4 minus a negative 13?
9.
Negative 4 plus 13, which is
9.
9.
Absolute value is 9 is 9.
So if you got 17, you are absolutely right in answer that.
We changed it.
But you're wrong, Rachel.
This is exactly what I drew number one.
Right, oh, are you writing out the wrong one right there?
No, that's the right one.
Keep
What?
making fun of me.
That is correct.
Here, let me just erase these real quick.
Rachel,
When you're finding the difference between two numbers, subtract.
Okay.
So if you put negative 4 minus 13, you actually were accurate.
Okay.
You understand?
Yes.
All right, next one. How'd you do it?
I'll do it on number one.
Okay, I got that one.
Okay, how do you do with the absolute value? 5 minus a negative 2, which makes that
7.
7. How about over here? 3 minus 15, which is
Negative 12.
negative 12, which is,
Oh, well.
okay, are we understanding? Yeah.
Why are we doing that?
Don't mess up your negatives.
I just read the board.
Still too much talking. Voices are up, eyes are up. Are we ready? Are we okay now?
I got
Yes. I just realized something.
We are. Can we turn done? We're almost done. All right, we are. What's the root word of communicative? What's the root word of communicative? Why are you talking? Root word of communicative. You are there. Commute. What's commute mean?
Addition.
Oh, like
dry
places.
Okay, I would say dry places. What are you doing when you're going from this place to this place?
moving.
You're moving. So commutative means they move.
Yep.
Got it? So that means A plus B, is that order going to be the same on the other side? No. So if the order changes, it's commutative. Addition or multiplication. Associative. What's the root word of associative we are? Associate. Okay, when you're at the football game, who do you associate with?
My friend.
Your friends or your group. What if I'm associating with Sierra and she makes me mad?
You're not associated.
You're gonna go what right now? I moved to a different group.
And then you tell them crap about her and then the whole.
Yeah.
You commute to the.
Voices are up. So associative has to deal with grouping. Your group changes. Does your order change?
No.
No. So if these 3 are working together, and I'm going to say these 2 are working really well. All right, they're doing well. They're their little group. Okay, now Eric makes her mad. Now who's she going to work with? Rochelle. Now, did they change position? Rachel, sorry. Rachel, did they change position?
No.
No, they just changed groups. So were their positions changed?
Oh.
What happens when their positions change? What law is that? Commutative. Okay, so here, ABC stays ABC, just your parentheses change. Distributive. Distributive means what?
How about distribute?
You are. If I bring 30 cookies and I gave them to you, what would I expect you to do?
Eat the cookies. Take one of them.
Distribute them to
Myself.
who? No.
I wouldn't give them away.
Everyone.
Everybody gets that. So distributive means it gets multiplied to everybody in the parentheses.
Yes.
The A goes to the B
They go to the
and the C. Okay, identity and inverse, two most messed up questions. Identity, what's identity in English? Tyler,
Tyler, that's what
identity. If I ask you what your identity is, what would you tell me? Yes, it gives you yourself back. So whatever is in the problem, you get itself back. What's the identity of addition?
You add something.
Add by
in.
what?
What?
I myself. Myself.
I add 0, because 0 gives me itself.
Yeah.
What's the identity of multiplication?
You times it by
One.
1.
Okay, what's the inverse in addition?
5 by 1.
5.
It's addition,
Subtracted by-
opposite. So if I say the inverse of 2, the additive inverse is
And negative 2.
negative 2. What's the multiplicative inverse?
Half.
Yes, inverse. Okay, now I know Jacob got that, did the rest of you get that?
Yeah.
Inverse of A is negative A, because it gives me 0, in addition. Okay, when I'm in multiplication, the inverse of A is 1 over A, or it's reciprocal, to give you that. Are we good? Okay, let's see how well you did. Write them down.
Can't wait.
What did you get for
First one! What did you get? Go. Associative, everybody agree?
Not just, right.
That I wrote wrong?
That looks amazing.
Associative, we regroup. They're in the same place. 3 is first, 5 is second, 2 is third. First, second, third. Nothing moved. So it's associative. Second one. What did you get? Christian.
Commutative.
Commutative. Why?
Because they're in different order.
Who's in a different order?
Groupings.
5 and 2. They flipped. Commutative. Next one. Leah. Distributive. They went through to each other. Last one. Okay. Identity. Okay, I would like you to give me an example of inverse here. I'll start. 2 times what?
2 times negative. I don't know. Negative 0?
I don't know. 2 times negative 2, whoops, sorry, equals what?
Negative 4.
Negative 4.
1 over 2. Yeah.
Oh, we have to do 0.
I need to get to 1 if it's multiplication.
1?
1 over 2.
If it's multiplication, yes, I need to get to 1. So what do I multiply by?
Oh, 1 over 2. Okay, sorry, I was real confused for.
Are we there? Inverse.
Yes.
Yes?
Yeah.
All right. Next one.
Next one.
Go, let's see what you know. Work with your partners, see if you agree.
Oh.
Okay, step 1. What do you think you do? Alexis. What? And what did you get? Okay, stop. Who thinks they know what to do next? Jacob. What am I distributing?
Negative 2.
Oh. Yeah, that was right. I want to go to be wrong. Yeah, negative 2 is what you distribute. I was so hoping you had that wrong. What did you get?
Why are you so mean to me?
I'm so sad. And then what?
Why do you want to do wrong?
It's funny.
Because she doesn't want us to succeed.
Well, guess what usually happens here?
Sometimes.
They distribute a positive 2 and then they don't have that negative sign, then they get all the wrong answers and you did it right.
Can you still do that?
All right. What?
Yeah, you can. We just got to make
Minus sign
sure.
there.
If you do, then you have to put parentheses. So at the end, you have to have a negative 10 and a negative 2. If you distribute the 2 without the negative, that negative would still have to be outside the parentheses. You wouldn't have cleared them. Did I answer that?
Yeah.
All right. Who would you combine?
But y squared.
Okay, let's go. 28x squared and what?
Negative.
Giving you?
18x squared.
Next,
19,
Plus
21,
19x.
19x. We're done.
we're done, homework time.
D11.
Okay, tell me why the homework